All right, so you saw this child making some pretty big errors, right? Some pretty, you'd be surprised what you saw this. Actually, this child was demonstrating egocentrism, which is part of that transductive reasoning. Egocentrism is where, for Piaget, the child literally cannot take another person's perspective. So you saw this child reporting what he is currently seeing when he's asked about what is on the other side of the mountain that he witnessed when he was sitting in the other chair. Now, some people would argue, well, maybe he just doesn't remember what he saw when he was sitting in the other chair. But if he understood that he was supposed to describe what it looked like to the researcher, don't you think he'd be like, I don't remember? I can tell you what I'm seeing right now, but I don't remember what I saw when I was sitting over there. But they don't. None of them do. They instead report what they are currently seeing as if that's the answer to the question, what can I see? What's over on this side of the mountain? Piaget started testing egocentrism with things like this kind of this model where you could physically move the child around the three-dimensional model and ask them to describe what they're seeing, and then ask them to describe what the researcher is seeing. Or Piaget started it with describe what Dolly is seeing, and the doll would be sitting in another chair. Egocentrism is really kind of it displays itself in lots of circumstances with small children. I'm thinking of a time when I had my children in the back seat of the minivan, and I'm listening to the radio, and suddenly the kids are crying, and I'm like, what are you guys crying about? And they go, we wanted to stop at McDonald's. And I'm like, well, why didn't you tell me? Well, we did. They thought that when they spoke from the back of the minivan, I would hear them, and then I just ignored them. Apparently, I heard what they said, and I just ignored them. So we made a rule in the household where it's like, say mom, I'll say what, and then you say what you want. And it's funny because my now 26-year-old son continues to say mom, and then I have to say what, and then he'll tell me. So apparently my rules are quite profound. But because they could hear them, they assumed I could hear them. But this is also what makes it fun to kind of play hide and go seek with children in this age bracket, because they'll hide in such a way that like their whole body is showing, but as long as they can't see you. So, you'll walk in, the curtains only go down to just like, 2 inches below their eye level. So they'll be behind it, their entire body visible. And you're like, I wonder where they're hiding. I can't find them. Are they behind the couch? You go through this whole thing, but their whole body is showing, because if they can't see you, you can't see them. It's just classic egocentrism. So it's really, I'm being redundant with this because a lot of times people think, oh, I know what the word egocentrism means. It means selfish. But that's not what Piaget meant by that term. He meant literally can't take the perspective of someone else. Animism is another thinking error that Piaget said that they displayed during this period of time. And that's where they literally think that inanimate objects have animate beliefs or behaviors or whatever. So in the classic children's story, Happy Birthday Moon, the little bear, who must be preoperational in his reasoning, saw that the moon ultimately lines up underneath his hat that is being suspended by the branches of the tree, and that meant that the moon wanted to have the hat for his birthday. Like the moon wants something or can move itself volitionally to get underneath the hat, right? But to this preoperational bear, he's thinking, oh, well, the moon has likes and dislikes just like I do. It has needs just like I do. Like maybe the moon is hungry. Again, an old story from my children's childhood. I was driving my daughter to, a lot of fast foods in my story, Burger King. And she's looking out the window and she sees I pointed out to her the full moon, and we're like, oh, there it is again. And you know how when you're driving, it feels like the moon can be following you. Or if you live on the west side of the state, I always felt like that about Mount Rainier. It seemed like no matter where I turned, hey, there it is again. How'd it get in front of me again? So it could be the mountain, it could be the moon, it could be a lot of different things. It seems like they follow you. And in her case, she goes, the moon's following us. Maybe the moon's hungry too. Maybe it wants Burger King. Like, she tried to convince me to buy an extra meal for the moon. I was like, no, we're not doing that. That's cute. I think that's adorable, but we're not buying the moon food. But that was her logic between the ages of 2 and 6, of course, that, the moon would want what she wants. Artificialism. So Artificialism is sort of the opposite of, a natural explanation of things. And so, because they don't really understand how the natural world works, they oftentimes give answers that are based on things that they would understand, things that, people do, I guess. So, for example, what makes it rain? They might say something like, someone turned the water hose on. I've heard kids say things like, oh, God must be watering his plants, or things like that. Why is the sky blue? My mommy painted it that way, right? Like it was made for me. My mommy knew I'd want it like that. My mommy has control over something like that because, to little kids, parents are all powerful. What causes thunder? The angels are bowling, right? So first off, we've got these mystical, creatures called angels. So somebody must have explained this to the child. And then something very mundane, bowling, right? So these are what we call artificial explanations for natural occurrences, right? We've rooted these natural occurrences in something that the child understands that would happen, that people do, not that nature causes to happen. So that's really a common way of thinking when you're 2 to 6 years of age. All right, so just for fun, I thought it would be fun to see if I can make you feel like a preoperational child. So imagine a circle. I conveniently drew one for you. Now imagine that you're going to squish the circle so that the border is going to stay the same length, but now it's going to be an ellipse or an oval or however you want to call it. So here we've got, basically the same. Okay, so I attempted to draw something as an ellipse that would be roughly the same circumference, or I don't know what you call the border of an ellipse, as the circumference of the circle. Okay, so here's your question. Is the area of the circle going to be the same as the area of the ellipse? They've got the same border. Imagine, even if I didn't draw it correctly, imagine that they do in fact have the same length border. Will they have the same area? All right, so hopefully you answered that. If you're like a lot of my live face-to-face students, you'll say yes, because if the border is the same, the contents are the same. So I thought I'll try and explain to you, like we do with pre-operational children, try to explain, what really is going on. And let's see if this helps. So let's move our circle and our ellipse out of the way, and let's substitute something that's a little easier for us to manage than circles and ellipses. I went all the way through calculus, but I still would prefer to talk about squares if I could. So let's imagine that we've got a big square that's made up of a 2x2 grid of smaller units. Since we don't know how big this square is, I'm just calling them units. So this 2x2 unit square versus, let's say we've squished it now into what has basically the same border, but it only, now to be rectangular, it only needs 3 units, right? It's got a 3x1. So that the area of the 2x2 is 4 units and the area of the 3x1 is 3 units. They are the same proportions as the circle versus the ellipse. So if you were thinking to yourself, well, the ellipse has the same border, it probably has the same area. Hopefully this, putting it into, what I think is probably more concrete for us, using squares and rectangles, we're much better at that kind of area, helps to illustrate that the area can change even though the border is basically the same, right? Because I've got, 2x2 should be similar to 3 plus 1 is 4. Those should be the same, but it doesn't come out to be the same area because it's multiplication, right? And it turns out that with the circle and the ellipse, we don't end up with the same area. The circle has in fact got a bigger area than the ellipse does. Now, I tried to use something that a lot of us, especially as psych majors, some of you who are majoring in something else, you might be like, man, this math is so simple. How are you even pretending like this would be hard? But for some of us, really honestly, math is not our favorite thing. And as soon as it starts to look like geometry, we really start to, it goes past us. And so even as I'm explaining the reasoning and giving an analogy of rectangles and squares compared to, ellipses and circles, it still is kind of complicated. And so hopefully this kind of analogy helps you to see what the preoperational child might feel like. Here we are trying to explain to the preoperational child what's going on and why they're wrong. Look, all I did was pour the water from this cup into that cup. Did you see me add any? No. Did you see me take any away? No. Well, then why do you think this one has more? Because it's taller, right? Like that kind of logic that they have, even as you try to explain to them that their logic is faulty, they might even parrot back what you've said. Oh, okay, I guess they're the same, but test them tomorrow and they'll be back to the reasoning that they displayed today. They're not going to really be able to internalize that until they're ready to. Like Piaget is kind of right that children have to mature into the next cognitive stage, and until they're ready to, they're not going to start to display conservation. So Piaget assumed that the errors that kids made were due to faulty logic. And he said he would give lectures in the US and talk about this kind of faulty logic, that the children just basically were not ready biologically in their brains, ready to think correctly about the intrinsic qualities that they were being asked to judge, volume, mass, numbers. The textbook gives you all the different examples of what all he tested. And he said only when he came to the U.S., he gave lectures all around the world. He was Swiss. He would go all around the world. He said only when he came to the U.S. would audience members ask, is there a way to speed up acquisition of conservation? Is there a way that we can convince these preoperational children to think about mass, volume, number, that these things are stable? And Piaget was blown away by that question. He called it the American question, because he couldn't understand what the point was. He's like, let them be children. This is how they see the world. Why would you try and move them faster through this stage of development that they'll naturally move out of through experience with the world? Why are you trying to move them through it faster? And he couldn't understand. And it is kind of the way his perplexity at this question that he would get causes me to give a lot of self-reflection. Why do we want to speed them up? With my own daughter, when she was 4 years old, I captured her on video making these mistakes. And my husband was like, you just haven't explained it to her correctly. Here, let me explain it to her. Like he really thought that. I would take her to school with me when I had, live classes and she was in the perfect age. I would take her to school. She loved those days when I would take her to school so she could do it. It was like just a fun game for her. And in fact, she got conservation of number while we were in class. And I was like, this is the first time she's ever gotten this. But it was, my students wanted to explain it to her. My students are like, well, have you tried telling her this? And I go ahead, tell her this. Let's see if it changes her reasoning. And the student would try to explain it to her. And my daughter would act like she understood what the student was talking about. We would then clear everything out, do it again, and she'd make the same mistake. And the students are like, no way. Sometimes I have students who think that if their child doesn't make this mistake, it's because they're smart. But here's what I think might be happening. They're making the mistake, but the student isn't asking the follow-up questions that reveal the mistake. So if your child correctly says, they have the same amount of water, you're supposed to follow up with, how do you know that? And if you follow up with that question and they say something like, because I say so, or because that one's blue, or something like that, it's not because they realize that volume stays the same even if the object appears different, which even a kid who's going to get it right isn't going to say that. A kid who gets it right is going to say something like, because all you did was pour it from one glass to the other, right? I saw you pouring it. Something like that, that'll indicate I witnessed the transformation and it did not fundamentally change the contents of the glass, right? So you have to ask those follow-up questions if you want to make sure that the child really understands the concept. And that's the problem that a lot of people complain about with Piaget's claim that 2 to 6 year olds will be making these errors. They say, you know what? A lot of times kids don't know how to explain what they're thinking. And just because they can't explain it doesn't mean they aren't thinking it. So language, you're going to notice throughout this chapter, is a really important factor in cognitive development. Like once children can explain what they have going on inside their heads, we become clear that they're thinking in a much more sophisticated way than when they were pre-linguistic. So it might be due to language shortcomings. It also might be evidence of egocentrism, because if you use materials that the child is really familiar with, so for example, the cup that they usually drink from, and pouring it into, let's say, a cup that mom or dad usually drinks from so that it's bigger or different in size, a lot of times they will show better reasoning skills than if you use something that's brand new to them. So if you use Play-Doh to measure mass, as opposed to something that they're familiar with, as opposed to Let's see what else could be used to measure mass. Pizza dough, or something else that maybe they have never really handled before, or that they're not really familiar with. You're going to get more preoperational errors, those thinking errors, when you're working in a medium that they really don't understand. So that's the Piaget preoperational stage. Let's go ahead and take a break, and we'll come back in the next segment and we'll talk about Vygotsky and what he says about cognitive development.